Fuel and emissions test 9, fuel delivery and injection. First fuel filter in the sock inside the tank normally filters particles larger than what?
70 to 100 microns.
70 to 100 microns. And a micron is what again? What's a micron?
Really, really, really small.
It's a millionth of a meter. It's a thousandth of a millimeter, right?
That was close.
If it's tripped, which type of safety device will keep the electric fuel pump from operating?
Now, we all know about that inertia switch.
However, the inertia switch is not found on every vehicle.
Only on Fords.
And some Nissans and some Toyotas. Some Nissans have them, some Toyotas have them, but I've never seen one on a Chevrolet. I've never seen one on a Dodge. I mean, the inertia switch on your newer vehicles is also tied into the airbags, and if it's a hybrid, it's tied into that system too. So, fuel lines are constructed from what?
Nylon plastic and seamless steel tubing.
Yes, I guess it's good for it not to have a seam. That's both A and B.
Where's your page that you said you were missing? Where's your
Yeah.
page you said you were missing?
Are you missing a test?
Yes.
Go get Katie to print you one. Tell her you need both pages of this test right here. Wait a minute. What's this?
Yes, that's all what I did.
No, that's fundamental tips. Go tell her to print it. All right. Now then, what prevents the fuel pump inside the fuel tank from catching the gasoline on fire?
No air.
No air around the motor brushes, because they're making little sparks in there, you know. We talked about that the other day. They were putting electric fuel pumps in aircraft fuel tanks for years before they did it on cars, you know. What's the first vehicle that you know of that had an electric fuel pump in the tank? Some of those little pickup trucks had a little electric fuel pump on the side of the frame that would go toop, 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 you know, for the one in the tank. The old Chevy Vega had an electric fuel pump in the tank.
Vega.
Those old Vegas, yeah. There's one mechanic I worked with over there that was a real Chevrolet, you know, buff, Chevrolet nut. You know, everybody hated that Vega engine, that aluminum block Vega engine, because it was just really wasn't very good. And they had that old cast iron Duke, you know, like a half of a V8. It was, you know, and he used to say Chevrolet had to tune up and redesign to build something sorry. Yeah, early 70s. It was real old. I mean, we're back in early 70s. May have been late 60s even, and early 70s, but it didn't stay very long. Okay, let me see. A good fuel pump should supply how much fuel per minute?
Is it about half to 0.8 gallons?
Yeah. They used to do, I mean, basically, that is not I will tell you something, that is not anything that you usually ever test. Now, you don't usually test that. I mean, mostly pressure, you know, volume, you can tell if the volume's not right by, if you've got the fuel pressure gauge attached to the fuel rail and you've got it up there so you can see it. I've actually got an electronic gauge with a transducer on it. The transducer hooks up to the port on the fuel rail, or however you have to hook it up, and you bring it inside the vehicle, and you just got numbers on it that you can look at. This thing's heavy. It feels like a brick, but you don't really want to put a long hose on there and run gasoline inside the vehicle. You know, if the thing pops off in there, you've hosed the inside down with gas. Now, we have taken fuel pressure gauges and pulled them with a long enough hose where we could put them on the windshield and tape them on the outside of the windshield so we can watch the pressure. But if you are going to a pretty strong pull and you see the pressure falling off, or you can even do this. Let's have our fuel pressure gauge on there, and let's pull the vacuum line off of the fuel pressure regulator. That's going to raise the pressure about 10 pounds. You know, because when you got low vacuum, the pressure goes up if you've got a fuel pressure regulator vacuum line on it. The newer ones, a lot of them have got the pressure regulated back at the tank, and they're delivering a steady, you know, there's no return line, like on that Neon, that little Dodge Neon that we got is like that. It's got a returnless fuel system. And, but anyway, those kind, if you pull on the regular old return fuel systems, we pull a vacuum line. This is a really important, easy troubleshooting step, so y'all pay attention to what I'm telling you. Look at that gauge, snap the throttle. If the pressure falls, you got a weak fuel pump. Now, the first thing you're going to obviously do is you're going to make sure that you don't have a clogged fuel filter, you know, because a clogged fuel filter will make it drop off under a load too. But if you know the fuel filter is new, then you snap that throttle with and I'm talking about that vacuum gauge. You need to pull it off so it should stay steady at 40 or whatever it is with the gauge pulled off. whatever your spec is. Some of them will be 70 to 80, some of them will be 40 to 50, some of them will be 50. You know, you got to look and see what it's called for on that vehicle to begin with. Make sure it's in that range. Snap your throttle. If it drops, you're done. Something else I've done, when I was working, and somebody would say, I drive my car, you know, I draw a ticket, and I say, the car quits, I have to cool off before it'll start back up. And so I get it in there and put a, after I check the obvious stuff, I put a fuel pressure gauge on it, and I crank, you know, make sure it's got plenty of gas in it. And I crank the car up, and I'll let it sit there and run while I work on other stuff. And sometimes I've let them run 4 or 5, 6 hours, just sitting there running. And then the next thing you know, I go by and the fuel pressure's gone, and the engine's dead. I crank it up, the engine fuel pressure comes up, goes right back down. Now you know you got a bad fuel pump. See what I'm saying? You've seen it happen. You know the fuel pump's at fault. You know, and I've seen that. There was a Chevrolet pickup we had out here. That they would drive around on the other campus over there, and it would cut off, and they had to wait till it restarted. Now, occasionally on these Chevrolet pickup trucks, there'll be something to do with the security system, because on the Chevy pickup, if the security system fouls up, you know, your key, it makes you wait 20 minutes before you can start it up. You know, you'll have fuel pressure and all, but it won't start until the security system times out. That's so you can, you know, you're not totally stranded, you know. They do it that way. But anyway, just those are little troubleshooting things. That's engine performance stuff, but it's closely tied in with fuel and emissions, right? And that's why I'm saying that, because we're talking about fuel delivery and injection. Let me see. Technician A says fuel pump modules are spring-loaded so they can be compressed to fit into the opening. Technician B says they're spring-loaded to allow for expansion and contraction of plastic fuel tanks. That's supposed to be B, and that's B is what you're going to put down there. But I'm going to tell you another reason they do that. There was a time, not too many years distant, and you're going to see some vehicles like this, where the gas tank was like this, and the fuel, you know, you're always, incidentally, you're always going to have an airspace in your tank. So you're typically going to have it so even when it's full, you know, you'll have some airspace in there. Okay, you'd have your sending unit and all that, and it'd stick down in here like this, and they'd have the sock right here, and it'd be floating about an inch above the bottom of the tank. And of course your gauge, you know, your float would be here and all that, and then it's got wires going up there, going out, and everything like that. And then you have your fuel pump here, and then you'd have wires feeding your fuel pump. Now, what happens if that's not right on the bottom of the tank? And this is not anything they usually see.
Dean, president or something?
Yeah, Gene.
Not
Not
Gene.
Oh,
Dean.
oh, Judd, Crude Up. Yeah, okay. Okay. Hey, come here, Jim. Where's Jim?
He's by the car.
Okay, get him. Go get him. Go get him. Tell him that we'll get him took care of in just a minute. All right, but yeah, yeah. That's the campus director from up there. What did he tell you? How long we got?
He didn't say how long.
Yeah. Yeah, ask him when he needs it back. Catch him while he's still going. Tell him we're going to be out of here in a minute, but I need to know. All right. All right, you see this? They're spring-loaded. What I started to tell you was, what happens when your gas tank is not, it doesn't have much gas in it? When your gas tank doesn't have much gas in it,
It sloshes.
not just that, you've also got water, condensation up in here. And when you got that condensation in there, the water collects. And over time, if that thing is like suspended that far, you're going to get a layer of water in here.
What do you leave by 11 o'clock?
We can make that happen. He's got to do an oil change, but it's a vehicle inspection and oil change all it is. We'll get through here pretty quick. But when this here sloshes around in there, it'll get to where it'll pick up some water every now and then. You got me? So how we combat that, we do away with this design here. All right, let's just take this all out of here. We're going to do this a different way. And we're going to put this thing in here so that it's, you know, on these spring-loaded rods, and it's got a reservoir, and it's made so it's round right against the bottom of the tank, practically. And it's got little nibs. Now what does that do? What that does is it creates low pressure, and any water that happens to condense and run out here gets picked up and dealt with when there's not much of it. You got me? Instead of letting it build up, it picks it up in little tiny small amounts, and that doesn't cause really any problem. But if you wait till it gets enough in there where it's going to slosh, You know, you're gonna have a gallon or so in the bottom of the tank moving around, and then when it does one of these weaves and it comes up and it pulls a big drink of water in there, you know.
Water's not.
And so that's why this thing about the expansion and contraction of the plastic gas tank, that's okay, but that's not why they spring load them. It does that, and I don't know the guy. I need to talk to the guy that wrote this about this, because he just knows. The steel gas tanks in these Tauruses, like that one out there, have got that same kind of setup. Even if it's a steel or a plastic gas tank, it'll still be like that. And that's so they can get rid of the water that collects in gas tanks intrinsically. If you keep your gas tank full, it don't make water. Okay, let's move on. Let me see. Most fuel filters are designed to remove particles larger than what?
10 to 20 microns.
10 to 20 microns. Now, this is one of the things I'm telling you. This is what you learn. Those are stuff you learn in school. Are you going to use this engine, this fixing a car? No, you're not. I mean, this is just basically, you know, stuff that you need to just sort of kind of remember. And if you're talking to a customer that's a stickler or something for accuracy, and you tell them that, they're going to be pretty impressed. The amperage draw of an electric fuel pump is higher than specified. All the following are possible causes except
Corroded electrical connections.
corroded electrical connections will not make that higher. A restriction in the fuel line will, clogged fuel filter will, a defective fuel pump will. Fuel pump's being replaced for the third time. Technician A says the gasoline could be contaminated. Technician B says the wiring to the pump could be corroded. Which technician is correct about that?
I don't think contaminated gasoline is going to cause the pump to go bad.
Actually, contaminated gas won't, but bad gas will. If the gas is old, it'll destroy a pump. If it's just contaminated, no. You know, if it's got stuff in it, depends on what the contamination is. Yeah, B is actually going to be the one. The wiring to the pump could be corroded, and I've seen that before. You remember I told you that story about how I replaced the pump and I found out I had a bad ground?
Yeah.
You know, fuel filter has been accidentally installed backwards. What's the most likely result of that?
It's going to have lower power at high engine speeds.
Yeah, that's right, because it's basically supposed to go on through the outside of the filter and come out the inside. Got me? In other words, the way a fuel filter is designed, you know, you've got this filter like this, it's fluted and all that, and the filter needs to go through the filter and then come out that hole right there. Got me? It needs to come out in the middle. If you turn it around, you've got all that it's going in this end and having to come out the top, and it just really is going to restrict fuel flow. You know how these right here are fanned out around the outside. That gives it places for the contaminants to go and all that. Engine oil filter, same way. Comes in the outside, goes out the inside. Got me? All right. Now then, let's see. Number 10. 11, excuse me. Technician A says a fuel tank is either constructed of steel with brass plating for corrosion resistance or of polyethylene plastic. And Technician B says some fuel tank filler tubes contain an anti-siphoning device.
It's not in a tube, it's in a tank, isn't it?
Well, it's in the tube. It looks like it's a little ball. It looks like a little ball in a little badminton thing, and it can rattle around in there. You try to stick a hose in there, boom, it just hits it, you know. And but if somebody wants your gas bad enough, they're just going to knock a hole in the tank anyway. You know what I'm saying? Technician A says fuel tank accident and rollover protection devices include check valves and inertia switches. That's right. Technician A says most fuel lines are made of ABS plastic. Which technician is correct? That's A.
What the heck is ABS plastic?
I have no clue. I mean, maybe I should know that. Anti-lock brake system plastic? I don't know. I mean, I may be stupid, but I don't know what that means. Technician A says electric fuel pump types include rollover cell, gerotor, and turbine. Technician B says fuel filters remove particles that are 10 to 20 microns or larger in size.
C.
That's number 3. That's C, basically. Okay, you know, the roller, they got various different types of pump designs in there, you know. How long does the electric fuel pump run if the ignition's turned on but the engine's not started?
2 seconds.
2 seconds unless it's one of the second generation Power Stroke diesels, and then it runs 20 seconds. Go figure. The electric fuel pump is usually mounted in which of these locations?
In the fuel tank.
In the fuel tank, except for on the Bronco, and it's mounted on the rail. And there's one in the fuel tank too.
It's got a lifter.
There's 2 of them. There's one in the tank and one on the frame. Some General Motors electric fuel pump circuits incorporate a what that functions as a backup circuit to energize the pump relay.
C.
That's actually going to be B. Believe it or not, the oil pressure switch has got a wire. It's got when it gets oil pressure, it'll turn on the. You know, if you're there's a guy out there at the Video Warehouse when they were starting up his Camaro. And it goes, "Bah," he spun it over for, must have been, what, 20 seconds before it fired up. And I said, you need a fuel pump relay. He said, how do you know that? And I said, well, the oil pressure is what, it had to wait till the oil pressure come up, and then it closed the, you know, if it feeds the fuel pump through the oil pressure switch, whenever the relay fails, it'll still start, but it's going through the oil pressure switch. That's GM only. I don't know of anybody else that does that. As far as, you know, having the redundant circuit. Let me see here. Fuel pump pressure is too low after engine startup. Which of these could be the cause?
I say restricted fuel return line.
What do you think about that, guys? That's going to be an A, basically plug fuel filter. Too low after engine startup. A fuel filter will not, after engine startup, a fuel filter will typically not keep it from starting. And it's not going to make it idle rough. It's not going to make it misfire. Usually the only time a fuel filter is going to act up is when you're trying to pass a car. Or, you like you're running pretty decent, and then you go into it, and then you feel it cutting back. These throttle body injected Chevrolet pickup trucks, you know, the little TBI injection. If the fuel filter is stopped up on one of those, you'd swear the catalyst was stopped up. It's a strange feel. It don't feel like a fuel filter. But you're driving, it goes, just barely will pull. You say, oh, it like a potato in my exhaust pipe or something. When you get down there and change your fuel filter out, and you're good to go. You know? So. But I mean, that's only on the throttle body ones. Now, it does different on the other ones. They don't feel the same. Those little CSFI fuel systems, you know, it's supposed to have like 60 pounds of fuel pressure. If it's got 59, it won't crank. A lot of times, at 58, it can have a couple of pounds, not enough, and it'll be a no start. We're doing that fuel and emission test, you know. Okay, let me see here. Technician A says fuel filter is located in fuel supply line. Technician B says fuel filter is located in fuel return line. Obviously, you want them in the supply line. I don't want to put it in the return line. Technician A says the pressure check valve should hold system pressure for at least 5 minutes after the pump shut off. Technician B says a defective check valve could cause long cranking time. Now, the check valve is actually a little spring-loaded. It's in the pump. It's actually, the pump is here, and the pump outlet is here, and in here, they've got a little seat. There's a ball on that seat, and there's a spring. And when that pump runs, they're going to push that ball off that seat, and the fuel's going somewhere. But whenever you shut off the fuel pump, that ball is supposed to close against that seat, and the fuel pressure should stay there. On one of these multi-point fuel-injected vehicles, if you got somebody that says it starts hard, and when it's hot, the first thing I want to do is hook my gauge up, and I'm going to pressure it up, and I'm going to see if the pressure falls off. You got me? So if it falls off, typically it's going to be this. It can be the fuel pressure regulator. It can be an injector. Typically, if an injector is doing that, it'll actually run really rough when it starts up. But if it's been, you can actually tell if this is what's going on by turning the key on about 4 times, pressuring the fuel system up and letting that 2 seconds run, and then spin it over. If it fires right up, it's typically going to be that, but you can look at your pressure and make sure. Tell you something else, too. One dripping fuel injector can flood the whole engine bad enough to make it spin a long time before it starts. Just one. Or sometimes if it's dripping, it'll go boop, boop, boop. And he was at this van of Mr. McCurley's out here. She says whenever she cranks it up cold, it skips a little bit and it flashes the check engine light, P0303 code. And he put some plugs in it, checked the spark and all that kind of stuff yesterday, injectors clicking and everything. And so I told her, I said, what we're going to do with that is let it sit here like it's cold, start it up, shut it off while it's still skipping. In other words, don't let it keep running until it quits skipping. Shut it off while it's still skipping. Then you're going to pull the plug out, which you suspect. Or if you ain't got a P0303 code or whatever, you're going to pull them all out. And if you see one boiling steam off of it, you know, or if you see one that's wet with water, you know, you got coolant migrating into the cylinder overnight. And likewise, if I've got a dripping fuel injector, you know, it'll make them start hard. Sometimes they'll spin over when they're hot. They'll spin over. They'll take a while to start, and then when you first crank up, they'll run a little rough, and then they'll clean up their act. That's when they're hot. The other way is when they're cold, is when you're checking for head gasket coolant migration. When they're hot, if you do it, crank it up, skips a little bit, shut it off while it's skipping, pull the plugs out. You're going to see one of them that's sooty, usually, got black hydrocarbon soot on it. You pull the injectors, and the injector on that one, if the injector on that one is washed clean on its tip, there's a leaking injector. You see what I'm saying? You hear where I'm going with those two things?
Is that water you talking about?
No, there's 2 different ways. There's 2 different things that can make it skip when it first starts up and then clean up its act and run fine after that. One of them, if it sits all night, and you're gonna, crank it up cold, and it's to be skipping, shut it off. Especially if it's one that skips and it straightens out. That's what I'm talking about. Not one that skips all the time. But if it skips and then straightens out, and they say it runs good after that, we'll shut it off and pull all the plugs. If one of them is wet with antifreeze or it's got steam. If I see one that's a little bit wet, and I want to know real quick if it's antifreeze or not, I taste of it. If it's sweet, yep, it's antifreeze. We're going to put a head gasket on there, or it's got a cracked head or something. However, if the problem's happening hot, if you crank it when it's hot and it skips, and then cleans up its act, that's when you're going to shut it off while it's still skipping, pull your plug. You're going to have one that's sooty, with hydrocarbon soot, or, may even be gasoline, whatever, if it's leaking bad enough. Then you pull the injectors out. The injector tips ought to be dirty. That sounds counterintuitive, doesn't it? They should be nasty and, have crud on them. And one of them little suckers will be squeaky clean. And the squeaky clean one's the one that's leaking. The clean one's the leaker. And you put an injector on there. And that was something I developed. There was a Thunderbird that came in that had 3 bad injectors, and it made it hard hot. It spun for 45 seconds. And finally I found out what was wrong with it, because 3 of the injectors were really clean, the rest of them were dirty. I don't know how 3 of them started bad batch from the factory or whatever. And that's the stuff I stopped to explain that's not in any book. You got me?
That's funny, because I was going to ask you that about cracked head. I knew about if you take the oil filter out, it's got the milk and pull the dipstick out.
There's a bunch of different ways that head gaskets can blow. I mean, so there's not any one symptom that says, yep, Now, in other words, you can actually have coolant migrating into the cylinder real slow after it sits there. You can have it migrating in there so it doesn't cause a skip. If you got one that's skipping, you need to shut it off while it's skipping. And look, I had a Jeep Cherokee that was doing that on cylinder number 3 on that one. And when we finally pull the head off, you could see where antifreeze had been crusting up on the piston where it was going in there. And I actually could see where the head gasket was blown after I pulled it off. But it wasn't overheating. You see what I'm saying? There was no combustion going into the water, but there was just coolant migrating into the cylinder. You got me? You got to draw a distinction on that, because we're in engine repair too as well. And so whenever somebody starts talking blown head gasket, I want to say, how's it blown? Is it leaking oil? Has it got water going into the cylinder? Has it got water going into or has it got oil going into the, usually you won't have oil going into the water for the head gasket. Usually it'll be a manifold gasket if it's a V6 or something. So you got to be able to parse all this stuff, and I mean, if you see, I got water in the oil, that don't mean you got a blown head gasket necessarily, or you got a cracked block. Intake can let water go into the oil too, and that's just a simple intake gasket, and you clean it out as good as you can.
Can a radiator drain like that?
What do you mean, can it drain?
Like if you fill your radiator up and your car don't run hot, but then all of a sudden it run hot, then you look, you don't have anything in the radiator.
Yeah, your radiator, you're going to lose some water. If you got water and it's not going on the ground, and it ain't in the oil, it's going out the tailpipe. The head gasket. I mean, and it may not even have any symptoms except that you're losing water. See what I'm saying? So that's another way. Yeah, that's a head or a head gasket. And the head may not be cracked. You may just have a gasket that's letting it go by. That's when you pull the heads off and you take them to a really good machine shop and say, check it for cracks, do me a valve job. And then he'll tell you if it's cracked, because they got ways of doing it there. All right, let me keep going on here because we need to hurry. Let's see. 19. Technician A says the pressure check valve should hold system pressure for at least 5 minutes after the pump shut off. Defective check valve, can cause long cranking time. 19. Or a bad fuel pressure regulator can cause it too. Technician A says, hey girl.
See you in the middle of class. I'll come back later.
Yeah. Well, I'll be through in about probably 10 minutes if you can wait around.
Yeah.
Yeah. Because that car out there's got to go real quick too, and I got to get these guys out of here. So.
Okay. I can stop by the city of Boughton. I'll be right back.
All right, that works. All right. Let me see.
19 both technicians?
19 is actually, 19 is C. Technician A says the fuel pump relay is usually controlled by the PCM. Technician B says the TVI injector squirts fuel above the throttle plate. What about that?
Oh.
Pretty good. Yep, that's a good one. Why are some fuel rails rectangular in shape?
Reduce noise.
It's a noise reduction strategy, isn't it? But what about the ones that aren't rectangular in shape? What do they do about that?
They've got a thing inside.
It's got a pulsation damper.
Yeah.
It's got a little old diaphragm looking thing mounted in the line so you don't hear the injectors going click, 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 click. If you didn't have that, the fuel lines would be bouncing against the floorboard of the car and it'd drive you crazy, Which statement is correct? Port fuel injectors inject fuel above the throttle plate, but dirt's most likely to be
Well,
found.
where are you at?
Yeah, where you at?
Did I go to 32 when I should have gone? Sorry about that. I went to the wrong question. Excuse me. Which fuel injection system uses a MAP sensor as a primary sensor to determine base pulse width?
Mass airflow?
That's actually going, no, not mass airflow. It's going to be speed density.
I know that.
Yeah, speed density. Why is a vacuum line attached to a fuel pressure regulator on many port fuel injected engines? If it's drawing fuel into the intake manifold, you got a bad diaphragm in that regulator. Number 23 is basically going to be D. Creates an equal pressure drop across the injectors. And the reason for that is when you got manifold pressure low and you got atmospheric pressure, they say they're wanting it to always be the same. They found out later that wasn't a big deal. Which sensor has the greatest influence on injector pulse width besides the mass airflow sensor? Anybody know? That's C, basically, throttle position. Technician A says the port fuel injection injectors operate using 5 volts from the computer. Wrong. Technician B says sequential fuel injectors use different wire color on the injectors. In other words, a different wire color to operate the injectors. One of them will be the one that feeds power to them, be the same color. That's 25. That's B. Which type of port fuel injection system uses a fuel temperature and or fuel pressure sensor? Who knows?
The electronic return.
The electronic return of systems is correct. Dampeners are used on some fuel rails to reduce noise. That's that little damper I was talking about. It's like a little spring-loaded diaphragm that absorbs that. Where is a fuel pressure regulator located on a vacuum-biased port fuel injection system? That's number 28. B. The outlet of the fuel rail. Coming out of that fuel rail. Did I skip one?
I did.
All right. What type of device is used in a typical idle air control? They say a typical idle air control. Solenoid. Technician A says most fuel injection systems use the PCM to control the pulsing of the injector. That's right. Most fuel injection systems use the PCM to control the operation of the fuel pump relay. That's right too. All of the following statements are correct except A. O-ring seal the injector to keep fuel away from the windings. Pardon me? Yeah, actually, that's not quite so bad. Dirt and water are more likely to contaminate the injector if fuel level is low. Fuel cools the injector. Fuel makes contact with the injector windings. They're saying that D is the right one on that one. Let's go with that. We're going to whiz through this and we'll be through. And I need a quick vehicle inspection and an oil change. I've already got the oil filter, by the way. Number 32, which statement is correct? Port fuel injectors inject fuel above the throttle plate. That's wrong. Dirt's most likely to be found near the bottom of the fuel tank. Duh, of course. Dirt's more likely to float on top of the fuel. Now, wait a minute. Which one's correct?
That would be.
Which one's correct or which one's incorrect?
Correct.
B is correct. All of these methods can calculate airflow except.
I think all of them calculate the airflow.
Yeah, well, actually, load calculation doesn't calculate airflow. Which sensor is used to calculate the amount of fuel required using the speed density method? We just covered that a minute ago.
That sensor?
All of these are used.
Yeah,
TP, MAP, EC, and IAT. Technician A says all port fuel injected engines use the speed density method. No. Anytime it says all or always or only or, Technician B says throttle body injection system uses speed density method. Which technician is correct about that? B. Which term is used to describe the pulses of air flowing from the engine out of the intake due to time interval between intake events with a 4-cylinder engine? That's a long question. Which term is used to describe pulses of air flowing from the engine out the intake air intake due to the time interval between intake events? That's reverse airflow. Because the engine's a big breathing machine in between the operation of the pistons, you're going to have, the air, is puffing through there, So, I mean, you don't have to think about that much, but that's basically, you'll, sometimes be able to feel that. But which term is used to describe a TBI system where injector pulses once per second each distributor reference pulse? That's D, synchronized. Which of these describes a condition that results in more fuel being delivered? Long pulse width. And which of these is true regarding a port fuel injection systems? A, the intake manifold may be shaped and sized to fit the engine performance requirements. B, fuel distribution to all cylinders is equal. C, fuel is injected almost directly into the combustion chamber, almost directly, not exactly. All these are correct. It's actually right behind the intake valve where it sprays it in there, unless it's a GDI, gasoline direct injection.
That's all?
Yeah, that's all these are right. And which type of port fuel injection groups the injectors into two groups, with each group